Hello students, this is your teacher Abdullah Khan, and today we'll discuss very important topic, that is ionic bonding. Before starting ionic bonding, I would like to discuss the topic electronic configuration of noble gases. So first of all, what are noble gases? Elements that belong to group 0, or sometimes we are saying group 8 of the periodic table, is called noble gases. Helium, neon, argon, krypton, xenon and radon are noble gases. So the atoms of the noble gases are stable and unreactive. So they exist in nature as single atom, or you can say that monatomic form. Why are noble gases so unreactive, or why they are called noble gases? Noble gases have full or complete outer shell, means always in any atom there is very first shell, and first shell can accommodate 2 electrons, and the next shell and the next one, second or third shell, can accommodate 8 electrons. If we will discuss about the helium, so the atomic number of helium is 2. So in very first shell there are 2 electrons, so its duplet is stable. Duplet di means 2, and octet comes from octa, means 8. So what's about neon? Neon atomic number 10. So first shell there are 2 electrons, and second shell there are 8 electrons. So neon is stable because the inner shell there are 2 electrons and outer shell there are 8 electrons. So its octet is stable. Same for argon, krypton, xenon and radon. They all have the 8 electrons in their valence shell. Therefore, these gases are stable. Helium has the duplet configuration. All other noble gases have an octet configuration, means 8 outer electrons in valence shell. Okay, if noble gases are stable, then why do other atoms react? Why there is a chemical bonding? Atoms of the most other elements are reactive because they do not have the noble gas structure or configuration. In simple words, they do not have their filled duplet or octet. In their outermost shell, there are no 8 electrons are present. So they react to become stable. Atoms of these elements lose, gain or share outer electrons to attain the noble gas configuration and form compounds. In short, the stability criteria of atoms is to complete their duplet and octet. Chemical bonding. What is bonding? Bonding means interaction. What is chemical bonding? Chemical bonding means the interaction of atoms with each other. There are 3 basic types of chemical bonding: covalent bond, ionic bond and metallic bond. In ionic bond, atoms gain or lose electrons to attain the noble gas configuration. Always metals lose electron and non-metals gain electron. We will further discuss this concept. And what is covalent bond? Atoms share electrons to attain the noble gas configuration. One thing is very important. The ionic bond is always between metals and non-metals. It is very important. It is the part of definition. Metals plus non-metals. Non-metals. But the covalent bond is actually between 2 non-metals. 2 non-metals. So the exact definition of ionic bond is the bond between metal and non-metal due to the gain or loss of electron, and they become the positive and negative ion, is called ionic bond. And the bond between 2 non-metals due to the sharing of electrons to attain the noble gas configuration is called covalent bond. So we are discussing ions. What is ion? In previous lesson we discussed that atoms are stable, atoms are neutral. So what is meant by neutral? There are subatomic particles, electrons, protons, and neutrons. So neutrons have no charge. So protons, positive charge particles, electrons, negative charge particles. Number of electrons and protons in an atom is always equal. Therefore, the positive numbers and negative numbers will cancel out each other. It's just like if I will write there are 10 protons means positive 10 and there are 10 electrons means negative 10. So algebraic sum plus 10 minus 10, it's simple mathematic rule, it's 0. So overall charge on an atom is 0. But if an atom will gain or lose electron, then definitely it will not be neutral and it will become ion. What is an ion? Ion can be positive or negative. Positively charged ions are called cations, and cations, you can memorize the name of cation with that example that cat is a pet animal. And why cat is a pet animal? Because due to its positive behavior. So cation has the positive charge. By losing electron, cation will form, and anion has the negative charge. By gaining electron, anion will produce. An ion is a charged particle formed from an atom or a group of atoms by loss or gain of electron. Formation of cation. Atoms of metals lose electrons to form the positive charged ions called cations. Always metals tend to lose electron to become the positive ion. Group 1, group 2, group 3 and transition metals lose one or more than one electron to become cation. Let me give you the example of formation of sodium ion. There are 11 electrons in sodium atom. In very first shell there are 2 electrons. There are 8 electrons in second shell, and outermost shell there is only 1 electron. Sodium need at least 7 electrons to complete its octet, and it is very difficult to get 7 more electrons. Easy way is to lose 1 electron so its inner shell will complete. Sodium electronic configuration 281. So the sodium atom lose 1 outer electron to form sodium ion. If the question is why, so the answer is very simple. To achieve the stable octet noble gas configuration, its inner shell will complete. 2,8. Formation of sodium ion. Sodium atom loses 1 electron and then now it becomes the sodium ion, and it has the positive charge. We are using the brackets and we are putting the positive sign towards mostly right side, upper right side, and it is the standard form to present the positive ion. 2,8 is the electronic configuration. So why there is positive 1 charge? Sodium atom 11 proton, 12 neutrons and 11 electrons. Charge 11 protons means positive 11, 11 electrons means negative 11. So overall charge on sodium atom is 0. So sodium is neutral. But after losing 1 electron, now there are 11 protons and 10 electrons. The total charge plus 11 minus 10, the total charge on sodium ion is positive 1. Therefore, there is plus 1 charge on sodium ion. Second example is the formation of calcium plus 2 or calcium cation. The atomic number of calcium is